हेलो रोहित, am I audible? रोहित,
सर।
आवाज जा रहा ना?
हाँ सर, आ रहा है आवाज।
अच्छा अच्छा, ठीक। आज today we have again repeat the chapter theory of relativity. Theory of relativity. I will again repeat all these things related to theory of relativity. So just wait, some of the candidates they enter. Now in this theory of relativity chapter, first, you know, I think frame of reference, inertial frame of reference, non-inertial frame of reference, Galilean transformation. uh, Hello, Galilean transformation. Next, Michelson-Morley experiment. Concept of ether is required for Michelson-Morley experiment. Now, first we have to discuss about about the concept of frame of reference. Frame of reference. First, we first we know uh, what do you mean by inertial frame of reference. Just wait, just wait. So frame of reference is, you know, a system relative to which the motion of any object is described is called frame of reference. A system relative to which the motion of any object is described is called frame of reference. Now, example of the frame of reference I have already given. Suppose same example I will repeat. Suppose if a person is standing on the earth, observes that the velocity of the train is suppose 40 kilometer per hour. Velocity of the train is suppose 40 kilometer per hour. Then another person who derives a cycle. Just wait, I am sharing my notes. हाँ देखो तो दिख रहा है नोट्स. हेलो.
No, sir. No, sir. No, sir.
ओके ओके, जस्ट वेट. हाँ अब देखो तो आ रहा है. हेलो.
लोडिंग हो रहा है. यस सर, आ
Yes,
गया.
sir.
आ गया ना. सो जस्ट वेट, 9 कैंडिडेट्स दे इंटर. समीरान, विवेक, अभय कच्छप, श्याम प्रमाणिक, just wait. So now let the example of frame of reference is again I will repeat. Suppose if a person on the earth observes the velocity of train is suppose 40 kilometer per hour. Velocity of train is suppose 40 kilometer per hour. A person who is standing on the earth surface. Now another person moves on a cycle. He feels that the velocity of the train is suppose 10 kilometer per hour. We'll observe the velocity of the train is 30 kilometer. A person who travel with the help of a cycle and he feels that the velocity of the train is 30 kilometer per hour. Again, another person means third person which standing on the train. He observed that the train is at the rest condition. He feels that the train is at rest condition. It means the motion of the train has no meaning unless it is described with the earth, cycle or train. There are three steps. First step, one person which is standing on the earth surface, he observed that train is moving with a velocity of 40 km per hour. Another person who travel uh, in a cycle and he feels that the velocity of the train is 30 person travel with a velocity of 10 kilometer per hour. Then the person feel that the velocity of the train is 30 kilometer per hour. Now another person means third person is standing on the train. He observed that the train is at the rest condition. It means the motion of the train has no meaning unless it is described with respect to the earth cycle and train, earth cycle or train. There are two types of frame of reference. One is inertial frame of reference and another is non-inertial frame of reference. Inertial frame of reference means the definition is the frame with respect to which an unaccelerated body is unaccelerated, means the body is at rest or moving with a constant linear velocity, are known as inertial frame. So according to this diagram, we can say that the definition is a system of coordinate axes, which defines the position of a particle in 2 or 3 dimensional space is called frame of reference. Here there are 3 coordinate axes, and the coordinate axis means a system define the position of a particle. Suppose particle here, there is a point P. In this point P, a particle is placed at this point P. So the position of the particle in 2 or 3 mutual perpendicular space is called frame of reference. According to this figure, here x, y, z are the coordinate axes. And here I have written I, j and k. I, j and k are the unit vector along x, y and z axis. Here P is a point. In this point a particle is kept. Let r be the position vector of the particle at that point. Here here I have written r be the position vector at point P. The position vector of this particle with respect to origin. Here this point is the origin. Look my cursor. The position vector of the particle here, position vector of the particle with respect to the origin, we can write r is equal to xi plus yj plus kz. So here velocity of the particle at the point P can be written as v is equal to dr by dt, because r is the position vector. So particle velocity of the particle can be written as v is equal to dr by dt. So this dr by dt can be written in this form, and and is equal to here dx divided by dt I unit vector plus dy by dt j unit vector plus dz by dt k. Now acceleration of the particle, acceleration is equal to, we know that dv by dt. So here a is equal to dv by dt is equal to d square r by dt square. Frame of reference. So the definition of this frame of reference or reference frame is that a system of coordinate axes defines the position of a particle in two or three mutual perpendicular axes space is called reference frame or frame of reference. Now another is inertial frame of reference. First is frame of reference, another is non-inertial frame of reference. Means here I have written, just wait. Inertial frame of reference. Another type of definition means when a body is accelerated, unaccelerated, body is unaccelerated. It means suppose x, y, for inertial frame of reference, this inertial frame of reference, a body is suppose unaccelerated, body is unaccelerated, is called inertial frame of reference. Now, any coordinate system relative to which a body is in motion has coordinates x, y, and z. If the body is not acted by any external force, then if the body is not acted by any external force, then means there is no force act on the body, means F is equal to 0. So we know that F is equal to m into a. So in place of a, we can write m d square x by dt square is equal to 0. Now for y-axis, m d square y by dt square is equal to 0. Similarly, m d square z divided by dt square is equal to 0. This gives dx by dt is equal to ux, dy by dt is equal to ui, and dz divided by dt is equal to uz. That all ux, ui, and uz are constant. Here, ux, ui, and uz are the components of velocity along x, y, and z axis. For inertial frame of reference, if there is no external force x upon a body, means F is equal to 0, then in that case for x axis we can write md square y axis x is m into d square x by dt square is equal to 0. For y axis, m d square y by dt square is equal to 0. Similarly, for z axis, m d square z divided by dt square is equal to 0. This gives dx by dt is equal to ux, ui, and uz. Ux, ui, and uz are the components of velocity along x, y, and z axis. Now, second is inertial frame of reference. Here, inertial frame of reference. The frame with respect to which an unaccelerated body is accelerated, unaccelerated body is accelerated, is called non-inertial frame of reference. The definition is, again I will repeat the definition of non-inertial frame of reference. If a body is unaccelerated, unaccelerated body is accelerated, is called inertial frame, non-inertial frame of reference. So, according to this diagram here, we can say that Newton's first law of motion is known as the law of inertia. If a coordinate system in which the Newton's first law of motion holds very good, is known as inertial frame of reference. Here, S and S dash are the two frame of reference. S and S dash. S and here another frame of reference S dash. S and S dash are the two frame of reference and such that their orientation in space remains fixed. Means frame of reference are fixed and another frame of reference S dash is free to have S dash is in translatory motion with respect to S frame of reference. Let system S dash frame of reference moved towards S. So here O and O dash be the origin of the frame of reference S and S dash frame. So if S dash frame of reference is moving towards the towards frame of reference S, in that case O and O dash origin are coincident at a time t with the velocity v. Means if S dash frame of reference moving with the velocity v towards S frame of reference, then their origin O and O dash coincides at a time t. Then and here O dash here I have written S dash is moving towards S, means O and O dash coincides at a time t with velocity v, means O dash is equal to here O dash is equal to R v into t. S is equal to v into t. Equation 1. R here R and R dash are the position vector. Here P is a point. In this point, a particle is to be situated at this point. Then R and R dash are the position vector of the particle P corresponding to the two frame of reference. Now this R, small r is equal to R plus capital R plus R dash. Therefore, here I have written R, just wait, R is equal to R plus R dash, means R minus capital R moves in the left direction, so its sign will be changed. R minus R is equal to this R dash. It means R dash is equal to R minus R. Small r minus capital R. Small r is the position vector of the particle from the origin O, and R be the here capital R be the S is equal to V into T. Now putting the value of equation 1 in equation 2, equation 1 का value को equation 2 में put करेंगे. So in that case R dash is equal to R minus, in place of capital R we can write here V into T. So in place of this R we can write V into T. Now equation 3. Therefore, d square R by dt square is equal to d square R dash divided by dt square. If v velocity is constant, then d square R by dt square is equal to d square R dash divided by dt square. So frame S have acceleration d square R by dt square, and frame S dash have acceleration d square R dash divided by dt square. This is the concept of inertial frame of reference. Now another is non-inertial frame of reference. Non-inertial frame of reference means if a frame is unaccelerated, if an unaccelerated body is accelerated, is called non-inertial frame of reference. Just wait, Jisan Ahmad, Jason. When the frame, when the frame of reference is accelerated relative to an inertial frame, the basic of physical law, means physical law of Newton's second law of motion, becomes different. Such frame of reference having an unaccelerated motion relative to an inertial frame is called non-inertial frame of reference. Now, accelerated frame of reference. Another name of this accelerated frame of reference is fictitious force or pseudo force. Fictitious force और pseudo force. Accelerated frame of reference का दूसरा नाम है fictitious force और pseudo force. Just wait. Two people are waiting. Just wait. हाँ, किसी को डाउट है इनर्शियल फ्रेम और नॉन इनर्शियल फ्रेम में? Having any doubt? No. Okay, now let's start. For fictitious force, in this diagram, frame, here there are two frames, S and S dash. X, Y, Z and X dash, Y dash, Z dash are the coordinate axes of this frame S and S dash. P is a point in which the particle is situated, kept. Now, frame S, the force acting on this frame S is equal to F is equal to M into A. For initially we have talked about this S frame of reference. So in this S frame of reference, the force acting on the particle is F is equal to M into A, means mass of the particle is M, A be the acceleration of the particle. Another force, F dash, acting on this S dash frame of reference, moving with an acceleration A naught. Here, acceleration of this S dash frame of reference is equal to A naught given it, and the S dash frame of reference moving in the opposite direction. So the force acting on this frame S dash can be written as F dash is equal to minus M A naught, equation 2. The force on frame S dash with respect to S. The force on frame S dash with respect to S will be F dash is equal to MA minus M A naught, equation 3. Now we know that non-inertial frame S dash does not hold Newton's second law. So F dash is equal to M into A naught. M into A naught. Equation 3 can be written as F dash is equal to, here in place of M into A, we can write F minus M into A naught, means F naught with the force acting on the particle by this as this frame of reference. Here I have written, since F dash is equal to F naught, the force F naught is equal to means F naught is equal to ma naught. It actually exits but appears to come into the consequence acceleration of frame as dash with respect to s. This force is called fictitious or pseudo force. Now fictitious force F dash F naught, sorry, in place of F dash we can write fictitious force F naught is equal to m mass into acceleration of non-inertial frame with negative sign, negative reverse, means F naught is equal to m into minus a naught, means F naught is equal to minus m a naught. Fictitious force F naught, fictitious force can be written as F naught, yeah, denoted by F naught. Again I will repeat this fictitious force or pseudo force. Here there are two frame of reference S and S dash, X, Y, Z and X dash, Y, Z. Z dash are the coordinate axis. P is a point. In this point P, a particle is to be placed. Now the S dash frame is moving with the velocity v in the opposite direction. So the acceleration of S and S dash frame is a and a naught. Acceleration of both these frame of reference S and S dash is suppose a and a naught. So initially starting with this S frame of reference, if a particle if the force acting on the particle for S frame of reference, we can write F is equal to F is equal to m into a. Now the force F naught, F dash acting on the frame of reference S dash moving with an acceleration a naught is equal to F dash is equal to minus m a naught. Minus sign indicates that as this frame moves in the opposite direction, the force on frame S dash with respect to S can be written as F dash is equal to m into a minus m into a naught. Equation 3. We know that non-inertial frame S dash be the non-inertial frame. Non-inertial frame S dash does not hold Newton's second law. So in place of F dash we can write F naught. F naught is equal to m into a naught. Therefore equation 3 can be written as F dash is equal to F minus F naught. Again we can take an negative sign in both the directions. So minus F dash is equal to, here minus sign will taken into F minus and minus will be plus F naught. Minus sign will cancel. Therefore F dash is equal to F plus F naught. We know that F naught is equal to m into a naught does not actually exist, but in consequence of the acceleration of frame S dash with respect to S, this force is known as fictitious force. इसको हम अपग्रेड कर रहे हैं, इसके बाद फिर इसी लिंक में ज्वाइन करोगे, इसी लिंक में ज्वाइन करना है इसके बाद फिर से. So fictitious force can be written as fictitious force F naught is equal to mass into acceleration of non-inertial frame with reverse sign. Acceleration here a naught be the acceleration with reverse sign, means it moves in opposite direction, minus sign. Therefore, F naught is equal to minus m into A naught. So, you have any doubt? Inertial frame and non-inertial frame? किसी को कुछ पूछना है तो बोलो. हेलो, नहीं, ठीक है. नेक्स्ट, theory of relativity. Theory of relativity. In 1905, Einstein developed theory of relativity. According to this theory, absolute motion through space and deals with object or observer moving with relative velocity with respect to each other. 1905, Einstein developed the theory of relativity. According to this theory, absolute motion through space and deals with object or observer moving with relative velocity with respect to each other. Now, this theory of relativity can be divided into two parts. One is special theory of relativity and another is general theory of relativity. Special theory of relativity deals with the objects and system which are either moving at constant speed with respect to one another or are at rest condition. But general theory of relativity deals with the objects or system which are speeding up or slowing down with respect to one another. Speeding up means it moves in the upward direction, or slowing down means it moves in the downward direction with respect to each other. So these are the two basic two theory of relativity. In your university examination, question will arise that what is the difference between special theory of relativity and general theory of relativity. So in that case, you can write special theory of relativity deals with the object and system are moving with a constant speed with respect to one another or are at rest condition. But general theory of relativity deals with the objects or system which are speeding up or slowing down. Now, there is a word coming in Michelson-Morley experiment, and the word is ether. Concept of ether. Light. We know that light waves are transverse in nature, and a material medium is necessary for propagating of transverse light waves. If the light is propagated into the ether medium, then change in velocity depending on the direction of propagation of light with respect to the motion of the apparatus. Next is Michelson-Morley experiment. So the word ether is related with this Michelson. In this Michelson-Morley experiment, first we have we know the construction part of this experiment. So here, S be the source of light. Here, just S be the source of light, L be the lens. There are two half silver plates, A and C. There are two half silver plates, A and C. M1 mirror is kept at the point P, and another mirror M2 is kept at the point Q. There is a telescope attached with this system, whole apparatus. This is the construction part of Michelson-Morley experiment. Now, M1 mirror, this M1 mirror is highly silvered on their front faces to avoid multiple internal reflection. M2 mirror are highly silvered on their front faces to avoid multiple reflection, internal reflection. Here, plate C does not reflect light. These are the construction part of the Michelson-Morley experiment. माने कौन सा पार्ट क्या है ये अभी बोले हैं. नेक्स्ट अब हम लोग इसको डिस्कस करेंगे. माइकलसन-मोर्ले एक्सपेरिमेंट के आधार पर, ऑन द बेसिस ऑफ दिस एक्सपेरिमेंट, we assume that there are two frame of reference, F and F dash. F frame of reference is on the fixed condition, and F dash frame of reference is moving with a velocity d. O and O dash are the origin. This is the basic part of the Michelson-Morley experiment. Now we have now starting with this Michelson-Morley experiment. Arrangement consists of a monochromatic source of light S, half silvered plate A, inclined at an angle 45 degrees to the beam of light, and there are two mirror M1 and M2 are highly silvered on their front faces to avoid multiple internal reflection. It also consists of another plate C. Look my cursor. It consists of another plate C such that A and C have equal thickness and they are made up of same material mounted parallel to each other. The plate C does not reflect the light at all. A and C both are the plate. A plate is inclined with an angle 45 degree. The plate C does not reflect light. The beam of light emitted from a monochromatic source S. Look my cursor. S source with the help of this source S, beam of light emitted and fall on the plate A. Plate A means plate A is half silver and it inclined at an angle 45 degree. In that case, the plate A, due to semi-silver, divides the beam into two parts. One is reflected and another is transmitted. The reflected beam moves towards M1 mirror, and which is placed at point P, falls normally. Hence, it is reflected back towards A. Here there is a sign. Goes towards the point P and again return back towards the point A. And after being it transmitted, beam moved towards mirror M2 and falls, and this M2 mirror is kept at the point Q. After entering into the plate C, so it is reflected by the mirror M2 and interfaces its path QA be the path, while